Hello everyone. In this video, we're gonna discuss about classification using deep learning. So basically, we're gonna use keras and weights and bias in Python. So first, we're gonna ensure the WAN-DB is installed properly. So basically, it's a powerful experiment tracking tool. It logs training metrics, plots, and even model weights, so we can track performance in real time. So we import key libraries like NumPy, Pandas, TensorFlow, and WAN-DB. Then we initialize our WAN-DB project with some basic hyperparameters like batch size, optimizer, and loss function. And after that, we are gonna load our dataset. So we are using the built-in breast cancer dataset from scikit-learn. It's perfect for binary classification. We split the dataset in 80:20 ratio, therefore for training and testing respectively. And moving on to model building, this is our neural network. We have used a simple MLP architecture with dropout to prevent overfitting and a final sigmoid layer for binary output. And moving on to training the model, we train the model and the WAN DB callback automatically logs all key metrics and visualization. You can view them live on WAN DB dashboard. And after training, we plot how accuracy and loss changed over time for both training and validation sets. This helps us visually confirm the overfitting or underfitting. So the plot underscore model, therefore the model architecture, this helps us understand the architecture at a glance. And moving on to evaluation of the model and test set. Therefore, the probabilities are converted to binary values based on a threshold of zero point 0.5. So next we calculate the overall accuracy and generate a full classification report including precision, recall, F1 score per class. And therefore here you can see the overall model accuracy is around 94%. So the ROC curve shows the trade-off between sensitivity and specificity, whereas the AUC tells us how well the model separates the classes. The closer it is to one, the better. And moving on to precision and recall curve. For imbalanced datasets, precision recall curves are often more insightful than ROC. We also log this AUC to WAN-DB. So per class error analysis. So this is where we dive deeper. So for each class, we check if any samples were misclassified and print their actual versus predicted values. So basically, it's great for debugging or explaining predictions. So in short, we have just trained a fully binary classification model using TensorFlow and logged every part of the journey with WAN-DB from architecture to metrics, plots, and even misclassifications. Thank you.